What up, nerds? I'm Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I light up a cigar, I talk about CTFs, hacking, and other security-related topics. So we just finished a CTF. When I say we, I mean ConnectWise. So my employer, I am the manager of ConnectWise's Cyber Research Unit, or the CRU, and we've organized a CTF for Cybersecurity Awareness Month, which was October. And since it's October and Halloween is in October, we decided to make it all Halloween themed. We called it Let the Nightmare Begin. And we had this whole storyline where our bot we call Freddy in our SOC. So this is a real thing that we actually have. We have a bot called Freddy who does some triaging of alerts in our SOC. And so Freddy became aware, he became self-aware and decided to destroy all of humanity. And so the CTF was all about tracking down Freddy's actions and stopping him from destroying all of humanity with his low orbit ion cannon. So I'm going to go through some of those challenges later. Today I'm just going to go through the Crackmes. So there were 5 Crackmes that I put together for the CTF. So I wanted to go through those. A lot of people got the first few, but the last couple, Crackme 4 and especially Crackme 5, had a lot fewer solves. I think Crackme 5, only the 3 teams that actually completed all the challenges. So our first, second, and third place teams. First place was Bootplug, second place was a team called Hacksaw, and third place was CNWR, who's an MSP. They're the only ones who solved Crackme 5, so I'm sure a lot of people out there who participated, who may have given it a try, wanted to figure out how to solve that. So I'm going to go through all 5 of those. I haven't actually cracked all 5 of them myself personally, but I did write them all, so it shouldn't be too hard, right? But before I do that, this is CTF and Cigars, so I'm going to go ahead and light up a cigar. This week, I've got something called the Pistoff Kristoff. So I actually haven't tried one of these before. A lot of times I'll try it ahead of time, and I'll take some notes, and I'll kind of tell you about it. This time I did not do that. Instead, I've just did a little bit of research, and I'll tell you what my research says, and then we'll see if what I've read about it matches up with my experience. But this is the Pistoff Kristoff. It's got a San Andres natural wrapper. There's a Indonesian binder, and a Nicaraguan filler. So this is a full strength, full body cigar. This is going to be a punch in your face kind of thing. It is a Gordo, so it's 6 inches, 60 gauge. Um, and it's got a little pigtail there at the end. Let me go and cut that bit off. So based on what I've read, let's go and do the cold draw. So the cold draw is where you just kind of suck on it before you light it up. Kind of gives you a pre-taste of what to expect. So yeah, there's a little bit of sweetness, sort of like a fruity red wine, a little bit of chocolate, a little earthy. And from what I've read about it, it's since so the wrap the foot here is wrapped up, so it's gonna be really strong at the beginning. You're gonna get a strong pepper punch at the beginning, and then it's got kind of espresso red wine flavor. And then once you get about an inch in, that pepperness kind of mellows off, and it becomes a bit more leathery and earthy. And so that first third, once you get through that initial pepper kick, is mostly leather, with that espresso and red wine. And then once you get around the middle halfway point, the leather really intensifies, and you also get some cedar and oak notes in there. And then that last third is supposed to really sweeten out. So the earthiness, there's still some earthiness that rounds it out, but that red wine and chocolate that we get at the beginning comes back. The leatheriness backs off, and we get more of a sweet flavor. So that's what I'm expecting. Again, this is the first time I've lit one of these. So let's get this thing started, and then we'll take a look at some Crackmes. Oh yeah, there's definitely that strong pepper punch there at the beginning. That's pretty good. Ooh, yeah, that's good. Let's have a little coffee. It's a nice morning. All right, let's look at some Crackmes. Let's see, where did I put this stuff? Here we go. So we've got Crackme 1 here. Now I went ahead and saved some time and loaded it up in Ghidra. So Crackme 1 is pretty straightforward, and I've done some Crackmes very similar to this one. In fact, I think I reused some previous code and just changed a couple of things. But let's have a look here. So when you load things up in Ghidra, it'll ask if you want to analyze it. You say yes. And then we've got the disassembled version over here, all the assembly. And then here on the right, we've got the decompiled. So it's kind of put together some pseudocode that's trying to decompile the compiled binary. All right, so if we start off here, I went ahead and selected the main function. So we had a list of functions over here. Started off at main, which is where most programs written in C will start. All right, we defined some variables. Well, okay, we'll start off here. So we've got the main function. It's got 2 parameters passed to it, param1 and param2. So if you've worked with C, the param1 these would be the things that are passed to it on the command line. So so we're checking to see what parameters were passed to it. So first thing we're checking to see is how many parameters were passed. So there should be 2, one being the actual application name, and then the second one being the password in this case. So for Crackme 1, when you run it, it just asks you for the password, or you have to supply a password. Here, let me switch to to my VM, and we can see that. So yeah, so it needs an argument. So that's all we're saying here. That's Crackme 1. That's what we're looking at in Ghidra now. All right, go back to Ghidra. And this one's pretty straightforward. So if there are 2 parameters, by the way, if there's not, then we get that argument needs an argument. That's what we just saw happen in my VM a second ago. All right, so we defined a couple things here. So we're giving this is just some some hex data. We can decode that in a minute to local 15, some more hex to local D, and then 0 to local 9. Then we're passing, let's see, we're doing a string copy, param plus 8. So what we're looking at here is going to be where it's passed on the stack. We're looking at the password. So the password is basically copied over to this local 22 variable. And then we've got this, this is a string here, essentially. And this string is equal to, we're calling this encrypt decrypt function on local 22. So essentially what it's doing, we are assigning some variables here. We're copying, again, this is going to be the password that's passed, copying it to local 22, and then we're creating this thing called source, and we're converting it. We're doing something to it in this encrypt decrypt function. And then what we're doing is we're going to copy this local 2F. So what we'll figure out, okay, so we're copying source to local 2F. So again, that's the result of our original password once we've done the encrypt decrypt. And then we're going to do our comparison, and the comparison is the previous thing that we had, this stuff that we had assigned up here. And then if it's true, then we get a success. If it's a failure, then it fails. So essentially what we need to do is figure out what is this encrypt decrypt function. Hey, Red Anthrax, thanks for joining. All right, let's look at this encrypt decrypt function. So this is where the main work is doing. Well, so what, if we go back what I just looked at, the that variable that is defined at the beginning, whatever encrypt decrypt does, it should convert our password to that. And if we look here and see what's being done, so this encrypt decrypt takes the one parameter that we're passed to it, which is our password, and it's doing a while loop going through it all, and then it's just doing, this is the symbol for XOR, so it's just an XOR 42. So essentially, all this thing does is it checks to see if the password entered. It does an XOR, bitwise or XOR 42 against every character in that password that you pass to it, and then it checks to see if it equals this local thing. So we can just take this, and what it's actually doing here, and this is where you got to kind of looks like Gidra is doing a little bit of weird stuff. It broke up this string. This is supposed to be all one string, but if we just reassemble this string and then do a XOR 42 on it, then we can see what this is going to be. So hold on, let me pull up CyberChef. All right, and I'll copy. Oh, that is the wrong. Oh, wrong browser. Okay, there we go. We got the right browser. Let me copy these strings over. Let's see what we got. There's one string. Here's the other one. And then that last one is just 0, which is just a null byte. So that's kind of your clue there that this should all be one string, because what is it? C does everything in all strings and in null bytes. All right, and we can do a XOR 2. Okay, things are a little out of order here. Let me see. Let's reverse this. Oh, yeah, I actually missed that. There's also, it does a reverse function. Forgot it did that too. That should be in the... Or is it just the Indianness? Okay. I think it was just the Indianness, the way Gidra did it. But that's essentially that's it. So if you find that that string, and honestly, if you just ran strings on it, you would find this string in here. That's the variable. Just XOR 42 that, and then you get the password. So that was the first one. It was pretty straightforward as far as Crackmes go. And now we can move on to the next ones. All right, so we look at Crackme 2. And let's see, where did I put, there we go. All right, so Crackme 2 is somewhat similar than Crackme 1 in that it's, you know, once an argument. But however, if we pull this one up in Gidra, it gets a little weird. Like it's a little hard to determine what's going on here. And I think some people may have gotten to already have this one open. I'll just pull it in again. All right, let's pull in Crackme 2. We'll analyze it. Try to figure out what's going on with this. So there is no main function. We get to the entry and try to figure out what is this doing. And basically this is going to be, it's going to be kind of hard to follow. Oh, and I'm not even showing you my Gidra screen. Anyway, here we go. I pulled it up in Gidra. We don't see a main function. It's a bit hard to figure out what's going on. We could trace through it, but we'll just get confused, and we're not really going to get anywhere. So let me show you what's actually going on with this one. So let's go back to my VM. And screen, there we go. If we run strings on it, all right, notice this right up here at the beginning, UPX. What is UPX? So this is something you want to watch for when you're analyzing malware in particular, but looking at anything. UPX is a common free open source packer. So it's used by a lot of malware, so I've had a lot of experience working with it. Hello, ET Kid, we're doing some Crackmes today. So yeah, UPX is a packer. That is essentially a packer will take a binary and it will compress it, maybe encrypt it, and makes it so that you can't, it's supposed to make it a little harder to reverse engineer. It's often used by malware to help prevent detection. So when you're looking at detecting malware, there's a couple ways you can do it. You can, of course, look for hashes, but hashes are easy to get around because you change one bit in your file and you've got a completely different hash. But you can also use something like Yara, and so Yara is going to look at different strings of different things inside of a file. But if you pack it, then all that stuff, since it's compressed, I'm having a hard time keeping this thing lit today. Anyway, when you pack it, you don't have all those strings. So everything's been either compressed or encrypted, and so things like Yara and string matches inside the file aren't going to work. And so a lot of malware will use different kind of packers, and UPX is a common one that you'll encounter. And in fact, it's so common, it's actually really easy to decode. If you've got, you can do, this is on Kali, just apt install UPX and UPX-D. And there we go. It's now unpacked. We look at the strings now. Strings, crack me 2. There we go. All right, so it looks quite a bit different. There's no UPX. And I didn't go through the whole thing, but we would have noticed when we look through it. So normally you're looking at strings, you'll see a bunch of ASCII strings inside of it. And there weren't any, or weren't very many, if any at all, in that other one. That's usually a sign that it's packed. You can also look at the entropy, and that'll tell you it's packed. But those are some things you want to look for. But yeah, if we look through strings here, see, there's a lot of like strings that we can find here. So now we can see that it's actually been unpacked. And we could pull this up in Ghidra, but there's actually, if you give me a second here to find it, we keep looking through here. And one of the things you should always do when looking through something you want to decode is look at strings, because you'll see some interesting stuff. I want to see if I can find what I'm looking for. If not, I'll have to pull this over to Ghidra and we'll do it that way. This one's also pretty straightforward. I didn't make it too hard. I just packed it. Was all. So if you tried to disassemble the packer, you'd get really confused. But if you, oh, there it is. Yeah, so if you look at that, that may look familiar to you. That is a Decrypt encrypted password. So we've got our, this would be the salt, and then this is the password. So if you've ever looked at like an Etsy shadow file in a Linux system where the passwords are encrypted, that's essentially what they look like. So quick, easy way to crack this one, you can just pull that out, run it through John the Ripper, and you'll get the password. The password is in the, yeah, there are definitely different password formats. But yeah, so the password is in the what is it, rocku.txt, which is in Kali. So that's a word list that's in Kali. So if we just run John the Ripper, throw a rocku at it, it'll take a little while. I'm not sure how long it'll take. It might take 20 minutes or something. Depends on your system. So we won't go through that now, but just trust me, it's there. You'll find it. Okay, so let's look at Crackme 3. All right, we'll do the same thing. So this one's very similar, or well, it starts off similarly. So we can see it is also UPX. So we can try to unpack this one, but we get an error. So the header is corrupted. So what do we do with this? Well, I actually ran into this doing some malware analysis before, and I'm not the only one. If you do some Googling, look around for that error. I found this, somebody made a blog post about it. So we had an error about the p info size being off. Yeah, there we go. P info corrupted. So this is from let's see, vcodispot.com. Not sure how that's supposed to be pronounced, but vcodispot or something like that. And yeah, this is a nice little tutorial on correcting this very issue. So this is something that, again, that some malware authors have done. They essentially taken the file size, the p info, so it's 12-byte section in the UPX packed program header, and they filled it all with zeros. So it's the size of the unpacked file. Now, if you do some more research, what you'll find is the same information while it's in the header, it's also repeated in the footer of the file. So what we need to do is find the correct pinfo and pfile size in the footer, and then we can correct the header, and then we can properly decode the file. So let's see if we can do that. I haven't done this in a while, so let's see if I can remember what I'm doing. I'm gonna back this up just in case I screw it up. All right. Remember what hex editors I have on here. So let's just do this. Okay. What did I do? Yeah, like I said, I haven't done this in a while. Try to remember how to do hex editing in Vim. What is that command that I do? Okay, I got my percent on with this. There we go. Okay, so if we follow along in the blog, try to figure out where this header is. So it's, let's see, it should be at offset 80, right? Yep. Anyway, so right around here. All right, so that is 0, and that's where the pinfo and the pfile size are supposed to be. And they've been zeroed out. So we need to correct those. So we need to look at the end of the file. And let me see. So, all right, so what we're going to look for is the UPX. The actual character is UPX near the end. So let's search for that. So here it is at the beginning. Here we go. So here's UPX at the end of the file. And let's see if we can figure out which values we need to fix our header. All right. So let's see, after the UPX, looks like it's 20 bytes after that. Let's see. So I'm not here. We'll switch back to the blog so you can see here. So this is the example that this blog shows. So we can see we've got the UPX here, and then relative to that, we've got 5 bytes at the end. And then there's 16, should be 16 bytes in one line. And then we've got these 4 bytes should be the file size. So I should have tried this before and made some notes, hey? All right, let's see if we can make this work. So I think what we're looking for, 2, 3, 4, 5. Okay, so it should start here, I believe. Or would it be here? Give me a sec while I look back and forth here at the the site. He doesn't say exactly where the offset's at. So I think we're looking. Yeah, if I'm, oh wait, nope, hold on, I didn't see that there. I was looking at the wrong UPX. I was looking at this one, but it's actually starts at the end of this one. Okay, so that would be these 3 bytes, and then we've got this one, 4, 5. So, all right, I think that's it. Let's give that a try. So 0C004913. Okay, well, let's give that a try. 0C004913. So let's go back to the beginning. Let's try it. All right, let me look again, make sure I'm doing this right. Nope, I'm not. Hold on. It wasn't at the... All right, I'm probably screwing all this up. Thought I'd just wing it, see what happens. What could possibly go wrong, right? All right, let's convert it back. If it even works now. Hey, it still works, so there's that. Nope. All right, it's still fucked up. The best time to do live demos is when you haven't prepared for them. Well, hey, this is why I made a backup, right? Let's spell that correctly. Okay, let's start over. Hold on, I've seen a couple of different blogs about this. Let me see if I have one that has a little more info. Actually, yeah, this one's a little bit better. Okay, so this is something by Cujo.com. And they actually have the UPX header here and the correct format. Okay, so we've got a 12-byte header before each compressed block. The uncompressed size, compression algorithm, filter ID, parameter unused, etc. The trailer. So we've got a checksum, UPX magic, loader size, version info, UPX format. We've got a block size. Okay, so I was looking in the wrong place altogether. I was looking up here in the offset 80. That seems to be part of the problem. Okay, I think that's this clarifies things a little bit more. Let's go back to our VM and let's try this again. Oh, I just realized part of my VM is off screen. Let's resize this a little bit. There we go. Okay, we'll get this right this time. So in case you're wondering what I was doing there, for the hex header, I'm just using Vim, and then I'm not sure it's showing up on screen or not, but colon percent exclamation XXD. That takes the buffer, so it takes everything that's currently loaded into Vim and it runs it through XXD. XXD just converts it to hex. And then at the end, I'll do the same thing with XXD-R that converts it back to the binary format. So it's just a way of doing hex editing using Vim as your editor. Vim was very important in our CTF. Freddie, it was his favorite hex editor, and actually you had to exploit Vim to get to the final challenge. Okay, so let's see, we've got, okay, so we've got this UPX here, and then I believe the file size, the header is after that. Or it's supposed to be after that. So that's actually, yeah, I was on the completely wrong line. So somewhere around here is where it's supposed to be going. So let's go again, jump down to the end of the file, search for UPX. Uh-oh. Did I get disconnected there? Just got to notice. All right, sorry about that. Looks like I got disconnected for a minute. Should be back now. Okay, so going back to what we were doing. Let's switch back to the blog I was looking at so we can all look at this together. Okay, so the pinfo or struct, or the binfo struct in this case should be at 118. It should be, so this is 110, 0, 1, 2, 3, 4, 5, 6, 7, 8. So right here. And then at the end of the file, we can see, let's see, where is that data? Binfo the same size. Man, there's a lot of info in here. Okay, so there it is in this case. So we've got, this is what I was looking for. All right, so we got the UPX magic bytes. There's a version and format, and then this should be the pinfo file size. So that's what we're looking for right there. All right, so if we go back and look at our file, so here's the UPX magic number. So that would be these bytes here. And then we've got 2 bytes that are the version and format. So that would be those 2 bytes. And then, let's see, it looks like it's 18 bytes. And then we've got 4 bytes that are the pinfo file size. So 18 bytes, we've got 2 bytes here. In case you're wondering, 2 hexadecimal characters are equal to 1 byte. So there's 2 bytes, 4, 6, 8, 10, 12, 14, 16, 18. So all right, so it should be those 4 bytes are a pinfo file size, I think. I was close before, but not quite there. All right, let's see if this works. Or hold on, let me go back and make sure I know where to put this. So if we look back at our appendix here, we've got the file size, which in this case it's 50D400. Okay, so the file size and the block size, these should be right here, 50D400. So in this case, we've got the UPX header here, or the magic numbers. We've got this size, the version and format, program ID, and then we got the P file size and the P block size. So those should be where we put those values. So it's 3008 0C00. Let's go back to the beginning. All right, we've got our UPX header there. And then, or sorry, not header, but the magic numbers. Then there should be the L size. So UPX magic numbers, 2 bytes are the L size, 2 bytes are the version and format. We've got 4 bytes, which are the program ID. All right, and then these 8 bytes here, so it would be the P file size and P block size. So that was, we're going to put the pinfo file size we got from the end. So it was 3008 0C00, 3008 0C00. All right, I'm confident this will probably work. At least 10% confident. Not x60. Okay, let's see if this will depack now. 3. Hey, it did. Look at that. All right, we unpacked it. Well, that was stage 1. Oh, but you know what? I don't have Gidra on that system. I have it on another system. So step 2 is to pull it up in Gidra. Okay. So that was stage 1 of that one. All right, let's switch to, let me do that again on my other system here. So you can see me do it again, and then we can also, let's see, Nightmare, Crackmes, right? Yeah. Then we can run it through Gidra, and I'll show you how to solve it. I won't go into a lot of detail there, but I'll show you the basics of and get you started on it. Okay, so that was right here, and it was 3008 0C00, 3008 0C00. XXD-R, PX-D, Crackme3. Aha, there we go, we did it. Okay, so let's pull this into Gidra now. All right, let's have Gidra analyze this one. So this one's not too bad now. It's just a little tedious. So I didn't really want to step through every bit of this. There's not a lot of complexity, like as far as anything. It's not doing anything too crazy from here on out. It's just, again, takes time and it's a little tedious. Let me find the main function. You know what? I haven't actually even disassembled this one, so I think there was a main function, right? Oh, let's see. There's some junk. Is there an entry? What did I do here? There's an exit function. That doesn't seem very useful. All right. There we go. There's main. Okay, so this one essentially is a regex. So it's going through and comparing each letter of the password that you pass it and comparing it to something. And some of it's pretty straightforward. Like we can see the first letter is B. So it's just going through all these different if statements. So if param 2 plus 8, again, being the password that we passed it, in this case, we're just getting the first character if it's equal to 8, sorry, B. Then we continue if the next one, so we got +1, so we're doing the next byte is equal to F. Then we continue. And then there's some of these functions in here. Some of these are just distractions. We can look at this. This actually just prints nothing. So they're just distractions that are thrown in here and there. Then we get, the next one is R. And then the next one, if it equals E, then it actually fails. So this is one that was, again, thrown in to throw people off a little bit. So you could actually have any character there as long as it's not E. If it's an E, then it fails. So I think that threw a few people off. Then we've got a D, and then a slash, and then an S. And then we move on to another function, part 2. So it kind of split it up. If it's equal to and, then we go on to part 3, and then JAS0N. So Gidra really made this a lot easier. When you actually look at the original source code, there's some XORs and some other things in there, but I think Gidra just did all the math for us, made it really easy. So the hardest part was fixing that UPX header. And again, that we saw a couple of blogs there where people have run into that exact same issue before, because that is something that you will run into doing some malware analysis, because malware authors will do that. So hopefully that'll be a useful skill you can actually use in your research if that's the kind of research stuff that you do. All right, so now the two tougher ones. So these really aren't that bad. I'll show you easy way to solve them. So these last two, Crackme 4 and Crackme 5, I actually, yeah, so I prototyped these in a programming language known as Brainfuck. So here's the original Brainfuck source code. So what is Brainfuck? Well, it's a bit of a brainfuck. It really is. Let's see. I'll show you the Wikipedia article. Maybe that'll help explain it a little bit. So it's an esoteric programming language. There's some other languages that are kind of based on this. Like one of our challenges use something called Pikalang, which is basically the same thing as brainfuck, but instead of using these symbols, they're using various forms of the word Pikachu. So if you looked at the code, it's like P P P Pika Pikachu Choo Choo Choo, stuff like that. But this is the entirety. This is everything you need to know about brainfuck. It's really just a matter of incrementing and decrementing values in memory by one. So you're using the left and right arrows, greater than and less than sign, to move your pointer, plus or minus signs to increment by one or decrement by one, period to output, comma for input, and then the square brackets for basically loops. So the only comparison you can actually do in brainfuck is if the value is equal to 0. So everything inside these brackets will continue to loop through until the value at the pointer is equal to 0. Now it takes a while to practice and really learn kind of how brainfuck works. But one of the things you can do with it, so it is a complete Turing complete programming language, and you can actually convert it directly to C. There's some tools online that let you do that. So that's what I did. I prototyped it all in brainfuck to make it kind of hard to follow, and then converted it to C. So let me show you what the C looks like after I converted it. Let's see. There it is. So this, again, it's just taking pointer values. So we've got this P equals A, and we're doing the first value is plus, or we're adding 8 to it, and then we're doing some math and so on and so forth. So essentially what we're doing, everything up here, some of it is just nonsense. So I just do a bunch of math, and then I reset it all back to 0. And then essentially what we'll do is we increment the first value in the pointer until it's equal to the letter W. And then it uses fput_c to output that. And then I change it, modify it till it's equal to the ASCII value for H. And then I output that. And so it ends up saying what is the password, doing it one character at a time. So it is important to know how brainfuck is working, and that it's using fput_c to print out characters, and then we get to where we're taking the input, it's doing fget_c for input. So if we run Crackmes 4, it says what is the password, we enter something, sorry you didn't get it, okay. Now I'm going to do this in GDB. And all I'm going to do, so I know that, and again, I'm skipping ahead because I know how this thing was written. What this program ends up doing is it asks you what is the password, and then it stores the password in the stack. Then it takes the value that you enter, stores that after it, and then it just kind of loops back and forth and decrements each value by 1. So like if the first letter was P, and it's in the stack where the password is stored, it's a P, and then like say that's PASSWORD. Yeah, so it'll go back to the beginning of the stack, subtract 1, move forward 8, subtract 1, and it keeps going back and forth. And the way the loop is set up is that both values should equal 0, and then it moves on to the next to check that both values are equal to A, and so on. And if all those values end up being 0, then you have success. Again, because the only thing you can compare in brainfuck is whether or not a value is equal to 0. So it does that. It's going back and forth. Does anyone know PHP? Hey, Flaky, I've used PHP before. It's been a few years since I've really got too much into PHP, so I couldn't really give you any advanced advice on that. but there might be some other white people in chat who can tell you more. Anyway, so my point being that the password is stored in the stack right after it asks you what is the password. And since it's using fgetc to get the password, we can set a breakpoint there. So this is GDB. I can just type br fgetc, we'll add a breakpoint there, run. And now let's see what's in the stack. So we'll use X. Let's look at 100 characters. We'll look at the hexadecimal. Actually, let's look at it in a string format. And $RSP, RSP being the stack pointer. It's the 64-bit stack pointer. And here we go. We can see the password. So FR3DDYS. So it's since it is 64-bit, each field it's in 4-byte words. So this is actually the first one. It would be 00. So these are empty bytes, and then F. But yeah, we can see the password here in the stack. So it's we didn't need quite 100. Let's just do 50. All right, FR3DDYSP4 $. So that was the password. So trying to take that apart in Ghidra would, there's a reason they call it brain fuck. It would fuck with your brain. And trying to step through it, it would also fuck with your brain. Brain fuck has earned its name. But yeah, that's how you find that one. So that's pretty easy, really. If you know a little bit about brain fuck and you figure out where that's stored. Again, you just have to look at the stack, right? Like wait till it says what is the password and wait till it's asking for input. Then look at the stack and the password is saved there. All right, now for Crackme 5, it's not quite so simple. What was it? fgetc. So for Crackme 5, it's pretty much starts off the same way, prints up what is the password, but this time the password is not stored in memory. Instead, what this one does, it'll take the password that you enter, and it's actually a pretty long one. Oh, actually, hold on. I'm gonna add another breakpoint for where it prints. So it's printing with fputc. Okay, then let's continue. Let's say what is the. Hold on, it's not the spaces. All right, so now let's look at the stack. So I put a breakpoint at where it starts printing, so it's going to start printing. And this one, actually, if you get the password correct, it says you have the correct password. Otherwise, it just gives you a bunch of garbage. Okay, so we're not really getting a lot of info here. Let me start over on this. Let's delete our breakpoints. Okay, so if you disassemble this one, like in Ghidra or something, what this one does, and let's look at the source code. This one's a little harder to explain, and I don't even know if the source code will help. Let's see. Man, this stuff just makes your head hurt. Here we go. This seems kind of useful. So after getting the password, what it does is it goes through each character and it just subtracts from it. And again, since we have to compare everything to 0, so if you're stepping through it and you see that it's subtracting all this stuff, you can probably assume that it's subtracting and it's expecting things to end on 0. So say if the first letter is T, which I think it is, what is T? Let's see, and ASCII. So like a lowercase t is the decimal value. Which one of these is decimal? That one. 1/16. So it's going to take the first character in the pointer and subtract 116 from it. And that should equal 0. And then if it does, then you've got the correct character and it moves on to the next. And it does that looping through every single character that you enter in the password. So as long as all the characters in the buffer end up equaling to 0, so again, we subtract from each one until, based on what is expected, then you have the correct password. So what we can do, what I did when trying this out, was just entered all Z's and then look to see what the final value was. So Z being, a higher letter, so Z would be like 122 in ASCII, or the decimal version of the ASCII character Z. So if you put in a Z and then your final result is the number 6, then you know it's subtracted 116 times, because 122 minus 6 is 116. So you know that the character would be T. So hopefully that makes sense. Let me do this again. So I'm going to put my breakpoint first on the fgetC, which is where we get input, just so it'll get to the what is the password. Okay, and it's going to do all the checks before it prints out, correct or fail. So I'm going to have it break the next time when it's going to print. All right, then we'll continue. And this will take some trial and error. But from experience, I'll tell you that the password is 21 characters long. So I'll put in 21 Z's. All right, and now we break where it gets to the fgetC, which is where it's trying to. No, sorry. Oh, I should have deleted that breakpoint. I think I just screwed. Okay, let's start over. Let's just delete all our breakpoints. Sorry, it was. Yeah, I forgot again, because we're doing brain fuck. It's not it doesn't take in the entire string all at once. It takes in a single character at a time, because brain fuck does everything in one byte. So all right, so let me do this again. All right, so I'm going to put my breakpoint on the fgetC run from the beginning, so that way it'll get through the what is the password. It prints that out. I'm going to delete my breakpoint. Then I'm going to put a breakpoint on fputC. So this is where it's going to print it out. So now when I continue, I'll enter my password I'm using as a test. It'll do all the math it needs to on that, and then it'll come to the conclusion that I've got the wrong password. But it's going to do the math on the actual values that I entered. So all right, so I did 21. Okay, so it's done all the math. Now if we look at our stack, so let's look at the hexadecimal values of RSP, and there we go. So it's starting here. Nope, sorry, it's starting here. Right, so there's the first we've got a null byte, and then we have our string, and it ends here. So what we can see, again, I told you the first letter was T. So since I entered Z, 122 minus 6 is 116, so that's T. And then we have 12. So we take the 122 minus 12, that's 110. So if we look at our ASCII chart, Just doing man ASCII. Make sure these numbers are right. Yeah, D was 122, so 110 is. Hold on, what did I? Sorry, this is hexadecimal, so it's not 12. It would be minus 18. Right. So 122 minus 18 is 104. And then that should be right. So that should be an H. Yeah. So the second letter is an H. And you go through and do that for each of these. For all 21 characters, and then you get the final password. The final password, hold on, let me pull it up. I'm not going to go through and make you watch me try to do math in my head for all those 21 characters. All right, so go through, do the math on all those. And then if you get the password, which is, that took persistence. Correct, there we go. Hopefully that made sense. Brainfuck is a lot of fun to play with, but it does fuck with your brain. Like it lives up to its name. But that's how I've solved it, and I saw some people talk about it in chat earlier, and I think they solved it kind of a similar way. Again, it came down to entering some values and just seeing what the math was to figure out how what it did after the fact, and then kind of doing some math afterwards and working that out. So that's Crackmes 1 through 5. Hopefully you're able to follow along with all that. If you have any questions, if you were participating in the CTF in your Slack channel, let me know. If not, you can hit me up on Twitter at BAMCTF. I'll try to help you out if you want to take a look at those. If you want to take a look at the challenges, the CTF was at itinsecure.com/CTF. We've still got everything up. You can't enter challenges anymore. Like the CTF's actually finished, so you can't enter anything, but you might still be able to look at stuff. If you want to look at some more write-ups, I'll put some on my Twitter as I get them, but also check out Redhead. Let's see, what was it? redheadsec.tech. So that would be Ross. Ross, he's been on my channel here before, and he's works for me on the CRU at ConnectWise, and he also helps build some of the more evil challenges in our CTFs. So redheadsec.tech, he's got a couple of write-ups here for the Freddy's compliance, Freddy's fave, and the repo. Those were some ones that people had a lot of trouble with. Truly an evil genius is Ross. And we'll do some more write-ups when next time I get on here, either next week or the week after, depending on my schedule. I'll go through some of the boot to root challenges, and we can do all that stuff as well. So those were fun. I especially like the last round because we had this chat bot in Slack you had to interact with, and you had to earn Freddy's trust, Freddy being the chat bot. And once you earn Freddy's trust, you had to send him a file and trigger an exploit. And anyway, I thought that was fun, as well as had some ASCII animation for some satellite stuff, if you guys caught that. If not, tune in probably in a couple weeks, and I'll share that info. So I think that's it for today. Thanks for joining. And until next time, if you're doing some CTFs and you get stuck, don't forget to try harder, don't panic, and always RTFM. Thanks.
It's a madman.